Hello, so now we're on 7.4, the sine and cosine ratios. So if you understood how tan works, sine and cosine work pretty much exactly the same, only there are different ratios there in our SOHCAHTOA. So really, what are they? What are sine and what are cosine? So we've got our SOHCAHTOA. So sine equals opposite over hypotenuse. Cosine equals adjacent side of our hypotenuse, and tangent equals opposite side over adjacent side. So really the tangent is the ratio between the lengths of the opposite side and the adjacent side. So it's looking at one divided by the other. How are they different? What's the ratio of the length? Sine, same thing, the ratio between the lengths of the opposite side and the hypotenuse. So now today we just start looking at the two that have to do with the hypotenuse. But they're all looking at this division sign, this division of the one side divided by the other side. So the ratio between the lengths of two sides of a triangle. So again, those sides are, we're always talking about, in this section in chapter 7, we are always talking about right angle triangles. The hypotenuse does not change. It is always the long side, the biggest length, the opposite of the right angle. It's always that one. The opposite and the adjacent sides change depending on which angle you're talking about. So if we're talking about angle alpha here, the opposite side, just as it sounds, is directly across, and adjacent means beside. So the angle beside it, the adjacent side. If we were talking about angle theta, then the opposite side is across, and the adjacent side is the one right beside it. So those two switch around depending on which angle we're talking about. The hypotenuse never changes, and these three are called the trigonomic ratios, meaning that they are the ratios between the length of two of the sides of a right angle triangle. You're never going to have to do a definition of this, but just so you understand kind of where it's coming from. Example 1, find the primary trigonometric ratios. So they want all three. So when they ask for trigonometric ratios, we are talking about all three in the SOHCAHTOAs. So let's do them in three groups. So writing out SOHCAHTOA at the top of this test, whenever you're dealing with primary trigonometric ratios, is obviously the first step. So we're just looking for theta. So step 1 is identifying which is which. So our hypotenuse, h, is 26. So it's always across from the right angle, always the longest number. Even if you're not given the angles, you're just given three lengths, you know that one's going to be the longest. All right, opposite. Opposite our angle. Suppose I could do this for both of them. Opposite. And let's do the two that use opposite. So you see each one uses two of them. And adjacent is the ones right beside. So each ratio uses 2 out of the 3. Each one is used twice. And then we just do the math. So sine theta, let's do A, B, sine theta equals opposite over hypotenuse. So that is 10 over 26. And we're just looking for the trigonometric ratios. We're not looking for the angles. So we're not going to do anything more than say that, do that division and say that this is approximately, with a little dot over top. And we're going to 4 decimal places. So the book likes 4 decimal places, so we'll work on that. Let's do all of A first. Cosine equals adjacent 24 over hypotenuse 26. Oops, cos theta. Oops, cos theta. Which could be brought down to 12 over 13 if we wanted to make that a smaller fraction, but we're going 2 decimals in most of these. So approximately, again, put that dot over top saying that this is approximately. Another way they show approximately is by putting 2 squiggly lines instead of 2 straight lines. So really, this is just all about, again, understanding your calculator. So opposite over adjacent. So tan of theta. So you've got to put that theta in there. There we go. So again, just going in with the answers. It's just a matter of knowing how your calculator works and remembering SOHCAHTOA. So this isn't too tricky if you have figured out your calculator. Approximately equal to 0.8421. So take a minute to play with your calculator. Make sure that you are able to get these answers. We're just doing division right now. So it's not going to be anything special. One thing to point out is since the hypotenuse is always the longest line, sine and cosine will always be less than 0, the trigonometric ratio. Tan is the only one that would have a value, that's possible to have a value greater than 1. Answers from the textbook. All right, so again, this is the opposite, where they've given you that this is 26 degrees, and they want you to figure out that what the ratio is. So you're really just putting this into your calculator. So some calculators, again, will have you press the sine button, and then a bracket, and then 26, and then a bracket, and then an equal sign. Some will want you to put the 26 in first, and then the sign button, and then the equals. Some won't have you do the brackets, some will have you do the brackets. So just a matter of knowing your calculator. So stop for a second, pause, figure out your calculator, figure out what you think these two numbers are, and then start again. And if if you've gotten those two numbers, then you've realized how to use your calculator. If not, you can check and make sure that it's in degree form and not radiant form. And then if that's not the problem, then you've got to figure out what order of buttons you need to be pressing in order to get that. All right, a real problem. And this is a real life problem. I lived on a ship for a year. I did this type of math with vectors in my math class, and we went up to the navigation, and the first mate talked about it, and they really do use this simple math to navigate ships, or at least tall ships. They have a computer program that helps out. It does some of the calculations for them. But in the end, it is this math. So those of you that want that real world connection, these ones are right to real world. So Captain Jack is navigating his ship to Port Harbor, which is directly north of his direction. So this P stands for Port Harbor. This is our ship. Our ship is J, Captain Jack. To compensate for an easterly current, so the current is pushing them in this direction. So to compensate for this current, he aims for a point on shore that is 5 kilometers west of Port Harbor, assuming that the point on the ship is 20 kilometers from his position now. At what bearing must Jack head his ship? So at what bearing? So what that means is, what degree does he need to be off of his actual location? So he needs to point the ship in this direction, and the current is going to push it back into that direction. So this is actually a vector problem, which you don't get until grade 12 or into physics. But the math is exactly the same. We're just not calling it vectors. So we need to know what degree is he going to point the boat. So we want to find out what theta is. We're trying to find that angle. So to do that, first think about what information do we have. Well, we've got a right angle triangle, so we know we can use our trigonometric ratios. So we know we have our hypotenuse, and we know we have our opposite side. So which one of these uses both the opposite and the hypotenuse? So we want to use our sine theta in order to figure this out. So it's really not that complicated. We've got sine theta equals opposite over hypotenuse. So the sine of theta equals 5 over 20. So we can do that in decimal form. And now this part is using our second functions on our calculator. So as I said yesterday with tan, same happens with sine and cosine. The opposite of sine is sine to the -1, which means inverse sine. So inverse means going backwards. So we're just going backwards. So when that jumps over the equal sign, we've got inverse sine of 0.25. So again, figure out how you need to do that on the calculator. Usually it is second function to get to that sine. And that will either bring up the sine -1, or you just press sine -1, and then it depends exactly like I said before. Do you have to have the brackets? And then of course there's no 0.25 button, but 0, then 2, then 5, then brackets. However you have to put it in. But in order to get to that sine -1, there's always a second function on your calculator. It's like pressing the shift button on your computer. So put that all into your calculator, and you find that theta is approximately 14.477 degrees. So if we're rounding that to the nearest degree, which we probably would not do in real life, but the buck is asking us to go to 1 degree. So Jack must head on a bearing of north 15 degrees west. So that's officially how you would write it, because we were already heading north and then we wanted to go 15 degrees. We are heading north, but we can't go directly north, so we have to go 15 degrees west in order to get there. Just knowing that 15 degrees would probably be enough on a test. I don't expect you to know navigation rules. Oops. Oh, I got the answer before the question. Oh, I don't have it. Okay, so I didn't leave myself for space for me to look for it. Number B, part B, Captain Jack is in communication with a submarine that is currently at the depth of 400 meters below sea level. I didn't leave myself a spot to actually do this, unfortunately. If Jack's radar tells him the submarine is 500 meters from Jack, due north of his ship, at what angle is the submarine located with respect to Captain Jack's ship to the nearest degree? So we want to draw this, and unfortunately I put the drawing on the same page. But we know he's 400 meters below sea level. So if we started off at the ship, and the ship is sitting on the water, we go 400 meters down. And we also know it is due north of us. We don't know how far north. But we do know our radar says he's 500 meters away. So our ship is telling us 500 meters. It doesn't show us the direction. And we know it's 500 meters from us. This is the sub. So we've got a bit of a triangle starting here, but we want to know what degree away from the ship he is. So now we've got 2 other spots. We got to figure out which ones we have. We have H with the hypotenuse, which is always opposite the right angle. We don't have our opposite angle anymore. And this time we have our adjacent angle. So we go back to our SOHCAHTOA. And so now we know we're using cosine because we've got an adjacent angle and a hypotenuse angle. So cosine of theta equals adjacent, I'm out of room, so I'm not going to write it again, over hypotenuse. So the theta equals the inverse cosine of 4 divided by 5, or 400 divided by 500. So that would be 0.8. And theta equals approximately 38.87 degrees. So again, it's nice to see this. So they've got a bunch of different suggestions on how you might be able to put that into your calculator down here. There's the working out for the school, and here is our final sentence. The submarine is approximately 37 degrees north of Captain Jack's ship with respect to the line that points straight down to the bottom of the sea. Yeah, so we needed a kind of an anchoring point. If we're going straight down as being one point, we might be looking at straight north as another point, and have drawn our triangle this way. That's would have been another option, but since we were looking at the 400 degrees, so then we'd end up with a different theta, or different angle there, the opposite angle. So be aware of how you're drawing your triangle to figure out which way it's supposed to be, because those would have been the two options. And I don't know, it doesn't say in the original question, so if you had done it the other way on a test, I would have been fine with that as well and gotten the opposite angle compared to going straight ahead. All right, example 4, solve a right angle triangle. All right, so this question is going to come up a lot over this year and the next couple of years. And to solve a right angle triangle means to find all sides and to find all angles. That's what that means. To solve a right angle triangle means find all the sides, find all the angles. So they give you enough information to start working. We know this is 90 degrees. We know that's 30 degrees. So then we can use, so I would start off by using what I know about triangles, that all three angles add up to 180 degrees. To figure out what that last one is. So if I've got 30 plus 90 plus angle C equals 180, I know that angle C is 60 degrees. That's my first one. Now finding all of the sides. So I've only got one of the sides listed, so I can use any one I want. But let's start with the 30. We always go back to the information that they gave us, just in case we mixed up one of our other pieces of information. It's like going back to the original equation to do your check. So I've got an angle of 30 degrees, and I've got the adjacent side to that one. So I am going to use that. So I want the two of my SOHCAHTOA that are going to use my adjacent. So I'm going to use CAS and I'm going to use tan. And I think the book is going to do this differently than I will. Nope, actually does it fairly similar than what I do. But there's probably many different ways you could do this. You could then go to that 60 degrees for angle C and use different trigonometric formulas. The cool part about solving a triangle is that there are many ways to do it. All right, so let's move on. So the CAS of A equals opposite over hypotenuse. So the cosine of 30 degrees equals 20 over h. So we're trying to find our hypotenuse. So now we need to figure out how we're going to rearrange our formula. So we need to isolate the h. And when it's on the bottom like that, it needs to move over to the other side. You can't move the 20 because then you would end up with still 1 over h, and that's not going to help you. So you need to move the h over and multiply it to both sides. And then move the cosine over. And then put that into your calculator. So that might be 20 divided by bracket, cosine, bracket, 30, bracket, equals. It might be 20 divided by bracket, 30, bracket, cosine equals. There might be a couple different ways to do it. So stop, figure out what you think is going to work on your calculator, then come back and we will show you that In this case, our h equals approximately 23.049 degrees. So the hypotenuse is side AB, or AC, sorry. So AC, oops, sorry, not degrees. Sorry, that's a length, not a degree. So is approximately, and they haven't given us units, so it's 23 long, but it hasn't given us units, so I don't know if that's centimeters or meters or inches or whatever, but it is 23. So now we need to find side BC, and side BC is opposite. Ooh, don't do that. Don't do that. Don't do that. It's bugging me. All right, so BC is the opposite side, so now we are going to use tan equals opposite over adjacent. So opposite is the one we're trying to find, or let's call it BC, over the adjacent side, which is 20. So tan of, and again, we're dealing with 30 degrees, tan of 30 degrees equals that. So now we can just move the 20 over, times tan of 30 degrees equals line BC. Put that into our calculator, and we end up with BC equaling approximately 11.547. Again, we don't have the units. The only thing the book has done differently is that they have named the three sides. We often name the sides in like this, where we put the capital letter as an angle and then the opposite smaller letter as the side opposite it. So when you see that, that's a common form of presentation for a triangle. So pause if you want to see theirs. So there are often more than one way to solve a right angle triangle. If you know the value of any side plus an additional side or angle, you can find the other measurements. Notice, however, that some answers may be slightly different due to rounding in the intermediate steps of the solution. So things to remember: SOHCAHTOA, which is here. You can find any side or angle measurements of a right angle triangle if you know two pieces of information in addition to the right angle. And understanding that opposite is across from the angle that you're talking about. Adjacent is the one closest to. Hypotenuse doesn't change, but the other two would change if we were talking about the other angle. Practice questions are in the post, and there's the overall homework.